Okay, let's look at the section 4.6, problem number 19, shadow problem. Right, a street light is on top of a 20-foot pole. So you have a street light here. A person who is 5 feet tall walks away from the pole at the rate of 5 feet per second. So he's 5 feet tall, and he's walking away at the rate of 5 feet per second. And at what rate is the tip of the person's shadow moving away from the pole? So right here. And when he is 20 feet from the pole, right? So that's the question. All right, so let's do that. All right, so first thing we do is we have to give variables for changing quantities, right? So the person is walking away, so the distance between the person and the pole is changing. So I have to give a variable. So I'm gonna call this guy x. So x is just the distance between the pole and the person. All right. Another quantity that's changing would be the distance between the pole and the tip of the shadow. So I'm gonna have to give a variable for that. So I'm gonna call that guy, so it's a shadow, so I'm gonna call it s. All right. Then what we do is try to do a little bit of geometry here. All right, so I'm seeing a big right triangle right here, right, using the tip of the shadow and the light and the bottom of the pole as the vertices, so you can have a right triangle here. So I pull that out, right? So we know that here this is going to be s, and this corresponds to 20 feet, so you have a 20 here. All right, and I also see a smaller right triangle right here. All right, so I pull that out here. All right, so this corresponds to 5 feet, so that person. All right, so this distance is right here is the difference between s and x. So we can simply write it as s minus x. All right. We notice that these two triangles, these are different in size, but basically have the same shape. So these are actually similar triangles. So similar, since you have a 190-degree angle here, and these two angles are congruent. So by angle, we know that these two triangles are similar. All right. So by similar triangle, we can use the ratio. So ratio of, for example, let's say s to 20 is the same as s minus x to 5. So let's write that. So ratio of s minus x over say 5, right? So ratio of this side to that side is equal to ratio of s to 20. Right? So because these are similar triangles. All right. So we got an equation, and I'm going to go ahead and simplify this, right? So I don't like fractions, so I'm going to go ahead and multiply by 20. So we'll get s minus x is equal to s, or actually, sorry, multiply by 20. So you have to actually multiply by 4. So it's going to be 4 and minus 4x, sorry about that, and that is equal to s. All right, I'm gonna just I can't really see it here. All right, so it's a minus 4x. All right, then I'm going to just move s over to the other side and combine with 4s, and move 4x onto the other side. All right. We can do that by subtracting s and adding 4x to both sides, right? Subtracting x, 4s becomes 3s, right? So negative 4x is on the other side. It's going to be positive 4x, right? Then we can just simply divide through by 3. So we get s is equal to 4/3 x, right? So we have a very simple equation, right? And what else do we know, right? We know that here, since person is walking away, so the distance x is changing at the rate of 5 feet per second. All right, so we know that given, right, given quantities are dx over dt, which is going to be equal to 5, which comes from here. So maybe I'll just circle here, 5 feet per second, right? So this is 5, right? And another thing is that this is when x equals, right, 20 feet, right? So x equals 20. All right, so that's all given right here, right? Then what we want is we want this guy. We want to know how fast is the tip of the shadow is moving. That's the rate of change of the distance s. So we're looking for ds over dt. All right, so we can easily find that. All right, so we have an equation here, so we can just take the derivative with respect to t. Right, derivative of s is ds over dt, which is what we're looking for. Right, 4/3 is just a constant multiple, so put that there. Derivative of x is dx over dt. All right, then we already know that the dx over dt is 5, so you plug in 4/3 times 5, which gives you 20/3. All right, so which means that the tip of the shadow is moving away from the pole at the rate of 20/3 feet per second. Right, that's it. I hope that this was clear.